Alright guys, so now we are at the last lecture of the semester, 7.5 application vector. So you need to basically use your ability to translate the reality into a mathematical expression equation. And so in this section, translate the word problem into vector, then do vector addition. In physics, sum of force equals 0 for a body at rest or moving at constant velocity, or sum of force equals mass times acceleration for accelerating body. So the first thing they are telling you is an airplane at a bearing of exactly northwest at the airspeed of 450 miles per hour. So if I represent a bearing with north right here, south right there, east and west, exactly northwest would be right there with an angle right there of 45 degrees, which end up for the bearing to be at 135 degrees from the initial side, right there. So that would be the representation of a vector defining the plane moving at a speed of 458 miles per hour. Now, it's going to toward a crosswind, and this crosswind with a speed of 125 miles per hour coming from north-northwest. So basically now, if I have a second representation for the crosswind, I'm having coming from north-northwest, and that would be the representation of this speed of 125 miles per hour. And so what do we have? We're having a knowing that our wind was right there at 45 degrees. 45 degrees. Oh, let me do that differently. So that was the wind. This is where we had 45 degrees. So therefore, the crosswind right there, it's 22.5 degrees. So right here, we have 22.5 degrees. And therefore, the angle right there, it's going to be 270 plus 22.5 degrees. And we end up to have equal to 292.5 degrees. So now if I take this wind and I represent this wind right there, and it needs to be as small as possible because it has to be a representation of 125, so the length of this vector has to be smaller than the other one, because the other one, the blue one, is 458, representing 458, and therefore the resultant, that is going to be your resultant R. Okay? And I know that the resultant R is equal to the crosswind plus the plane. Okay? Now, pretty easy, pretty simple to define the coordinate of R. R is going to have Rx, let's call that I, the vector being only on an x dimension, plus Ry, and Rx equal Wx plus Px, and Ry equal Wy plus Py. When I do the calculation, you end up to have R equal, well, R being 458 multiplied by the cosinus of 135. 135 being right here, and then we're having 458 sinus 135 plus, okay, that was px and that was py, plus 125 cosinus 292.5, 125 sinus 292.5. All right, I think it's pretty simple. So let's jump on the other one. Let me do the graph and I will get back to you. All right, guys, so we have a 225-pound sign held up with two cables fastened with a hook and on the top center of the sign. So right there, this is where you have the hook. The hook is right here, okay? Let's call that the hook. One cable making an angle of 32 degrees, right here, the other 45 degrees. And the question is, what is the tension in each cable, okay? All right, so once you are able to represent each tension and all the forces, what do we have? We have a sign, that's what we call the system that we are going to study. And the force applied to this sign are basically the tension in cable 1, tension in cable 2, and the weight of your sign. Now, because the sign is not moving, the force adds up to the net force, to a net force of 0. Well, basically, we're applying the first Newton law, and basically what we are saying is the sum of each force is equal to 0. So we are going to have T1 plus T2 plus the weight is equal to 0. Okay? So guys, if I want to express the vector T1, the x component of T1 will be T1 cosinus 45 degrees, and the y component of T1 will be T1 sinus 45 degrees. Remember, what I have is, if I project right here, we're having T1x, and right there, we're having T1y. And if I have 45 degrees right here, I will have 45 degrees. And so remember, the idea is to say that T1x divided by T1 equal cosinus 45. It's the same idea for T1y with the sinus. So once you are able to express each of the component of your vectors, you can express on the x on the x component equation, and so you have T1 cosinus 45 plus T2 cosinus, let me do that, T1 cosinus 45 plus T2 cosinus 148 equals 0, plus 0, I'm going to write plus 0 right here, plus 0, why plus 0? Because this one right here is 225 multiplied by 0, which is 0. And obviously, sum of the force equals 0. So on the x component, it will be equal to 0. Now, if I look at the y component, I will have T1 sinus 45 plus T2 sinus 148 plus the 225 sinus 270, and that is equal to not 1, but negative 1. Therefore, this is why at the end of the day, we're having the negative right here. So now what I'm going to do is from the first equation, I'm going to express T1. I could have decided to express T2. I decide to express T1, and I substitute T1 into my second equation on the y component. And when I do that, once I'm able to write all of these numbers, I'm able to factor T2 and find the expression of T2. Once you have T2, you can easily calculate T1. And at this point, you should have a question on your head puzzle helping you to define if the calculation you made is correct or not. Now, let me write a note for you that T1 and T2 are equal 286 pounds, which is more than 225 pounds, and which is pretty normal. Because if it was not, if it was less, that would mean that your cable is not able to hold the sign, and therefore your sign will be pulled down. So here's the representation of your problem. Slope 10%, your box, the force F, which is pulling up, the ground, the slope, which is holding your box, avoiding that the box is sinking down the slope. Wn would try to sink down the slope, the box. WH and the friction, which is WH, which is the horizontal representation of your weight, which is on top of the friction, trying to pull down down the slope your the box. So again, we're having the system, which is the box, the force pulling the box, W, which is the weight of the box, defined in two separate forces, the normal to the slope and the horizontal to the slope, Gn, which is the slope ground force holding the box, avoiding the box to sink in the ground, sink in the slope of the ground slope. So now if I want to apply my first Newton's law, I'm going to have F plus Gn plus F plus W equals 0. I'll let you look at your, you should have in front of you the picture. And so if you look at it, you will see that on the X component, the only force that you have on the horizontal will be F plus negative the friction plus negative the WH. Why negative for both of them? Because when you look at the direction of F and lowercase f and WH, you can see that they are in opposite direction. This is why you have negative F and negative WH. Same thing for Gn and negative Wn. When you look at your graph, your picture, you can see why I'm able to define that WH equal N sinus 10. And therefore, knowing also that the friction is 15% of your weight, I'm able easily, using from the equation of the X component, to calculate express F, which is pulling up, and therefore calculate the value by substituting F by 37.8 and WH by 252 multiplied by sinus 10 degree. And that is equal to 81.6 pounds. Now, if I do the same thing from the equation of Y component, I will be able to express Gn by adding right here both sides plus Wn. This is why I end up to have Gn equal Wn. And because Wn is equal to W cos 10, I'll let you look at it, and if you have any question, please let me know. You end up to have 248 pounds. Now, I went very fast. Unfortunately, I don't have a lot of time, but you can always pause and you will be able to find, you will be able to understand pretty well. I'll let you solve the last problem, but it's not very complicated because at the end of the day, it's just about writing tangent of the angle theta equal 0.12. And if tangent theta equals 0.12, that means that theta will be equal to tangent to the negative 1, 0.12, which is equal to 6.89 degrees. After that, I'll let you continue the problem, and I think you shouldn't have any difficulties. And if you have any question, please ask me in class. But work this out. Thank you very much, and talk to you in class.